Okay, let's go ahead and get started. Hello, everyone. My name is Marcy Samuelson, and I am Marketing Manager for the Developer Initiative here at Oracle. Thank you for attending today's Microservices Distributed Tracing from Traces to Operational Insights. If you have any questions during the webcast, please put your question in the Q&A area, not the chat, and we will answer your questions as quickly as possible. We have a number of people on the line to answer your questions as the presentation goes, so don't be shy. Go ahead and put them in the Q&A area when you have your question. This webcast is being recorded, and we will make it available shortly after the webcast concludes. Again, thank you for joining the Microservices Distributed Tracing from Traces to Operational Insights. This webcast will be presented by Avi Huber, Senior Director, Oracle Public Cloud. At this point, I will turn it over to Avi.
Hey, good morning, everybody. Thank you for joining. Through this session, I will describe our product, the very new APM, OCI APM, Oracle Cloud Infrastructure Application Performance Monitoring, and we'll then go through a quick, or not so quick, demo of the product and describe how to start using the product. It is available today on all our data centers, and there is a free version that you can start using it. Very quickly before we go, we all know that there's a huge investment in application performance. The market is several $1 billion. The larger monitoring market is even bigger. Still, 80% of the problems are being discovered only after the fact. And we all know the reasons, and I will not spend too much time on this. Basically, it's too complex. The applications are complex. They're running in many places, and we need more tools. We need the tools to be able to handle this type of complex application and complex environments. So with that, I'll just go and describe the tools that we are, or the set of the platform that we currently have. We Oracle introduced this observability and management platform in October. And application performance monitoring is the last step that was released a couple of weeks ago. The platform together uses is an OCI native platform. It's almost completely brand new, utilizing common APIs and common standards that allows you to work with all these components together. So not only that the monitoring data service is shared by all the different other services, so you get data from the database, data from the APM, and from logging analytics, all monitorings go to the same place where you can use the monitoring. You can also use integration between the product where you use notification from that is based on monitoring that created in one service to invoke some activity on the service connector hub to move data on another, and so on. And today we obviously concentrating on APM, and this is a full APM product that covers the whole gamut of what application performance monitoring mean. Which includes real user monitoring, synthetic monitoring, the server-side monitoring. But the portion that I want to concentrate on today is the distributed tracing, which is new. Distributed tracing started a few years ago, and this product was built from the bones as something that is rely on distributed tracing. So even when monitoring an application that is not a microservices application, we are still using distributed tracing concepts to monitor it. And the two major things here is that we are tracing every transaction across every technology and saving and storing all instances of all these transactions. Oh, wrong direction. A little bit of the architecture, very high level, of course. So think about the left side is your application that is being monitored. It may be running on OCI, It may be running on premise, maybe running on some third-party cloud. Once we instrument the application or by a tracer or by an agent, and I'll explain the difference in a minute, the data is being sent to us in APM. So the right side is our service. We instrument the backend, so your Java, your Node.js, whatever you're running your application on, and we instrumented the browser, assuming this is a browser application, this is an end user application with a browser. We also support the synthetic monitoring, which I'll spend less time on this session, that allows us to run a test from a scripted script that will run against either a browser or directly against a REST service, and will monitor the application from any locations from any of our data centers. The application exists right now in the 22 commercial data centers that Oracle has. Data arrives in the application and stored for a long period of time in our trace data store. It also, we collect metric from the services and calculate metrics that are based on the traces that arrives, the data that arrive into the service, and send them to the monitoring service where they are available for alerting, for dashboarding, and so on. So a quick explanation how Opentracing / Open-Telemetry works. This is actually the base of how we collect the transaction and how we do end-to-end transactions. In case you are not familiar with this, Opentracing was something started first by Twitter with Zipkin, and then by Uber with Jaeger. But the new standard that is being evolved is Open-Telemetry. It's being endorsed by most of the big vendors, as well as many individual developers. It's open standard, actually, and we adopt that as well. The way it works is simple, and the example here is using microservices on the title and the HTTP protocol, but actually it will work regardless, and I'll explain. So think about an application with a browser in the front, 2 tiers, and a back and a database. The first component that is instrument, and in our case that will be a browser, we'll put a JavaScript running on the browser, inject. And when the user, let's say, click on the checkout button on the browser, the agent, the trans here, capture this or intercept this HTTP request, the AJAX call, and add to the HTTP header trace ID. This is the first call, so it generates a unique trace ID. It's also generates a span ID. A span ID is the step. The trace is the transaction. So these two IDs goes into the header, and the tracer or the agent that runs on the second tier, in this case, the front tier of the backend, the microservicer, extract these headers from the HTTP request and keep them while the processing of this transaction go on. When this microservice make a backend call to something else, it injects the same trace ID and a new span ID, the span ID of this microservices, and so on to the backend. And now let's say we are looking at this SQL execution. The SQL executes something. The database currently actually doesn't have an instrumenter, so this SQL span actually will come from here. This agent over here will see how much time we spend on the database and take the span ID, the trace ID that was extracted from the header when it was the request arrive into this microservice, calculate the time, generate another span ID, and send this information back to us in the APM service. The request now, so the first call here that arrived into microservice B was a servlet, let's say, if this was a Java. The servlet executed the SQL, send the SQL span. Then the server ended, returned the HTTP response, and it sends the data about this span, about this execution in this step to our collector. Again, there was an HTTP call, so there was an HTTP client making a call to the backend. This HTTP returned. a span is being sent out, and so on. Eventually, the browser says, I got the Ajax call back and send the data back to the server. Each one of the span has the trace ID of that makes this come together, all these spans together, and the individual span, and each one of the spans knows the parent span, whatever span called this span. So together with this information, we can build back on our server the entire call tree. And that happened through all the services, no matter how many are there, and they could be hundreds or more. In this example, there are 2 spans per server. Actually, there can be more. I may choose to create a span here in between because there's some business activity that I want to measure separately. So I can configure it to send data somewhere between the outbound and the inbound call. This will also work. In this example, all this is a synchronous call, but it works exactly the same if it's asynchronous. This root span may return way before this span will arrive from here, because this call over here was asynchronous. Still, the tracing works. This is HTTP instrumentation, but same thing will work for other type of protocols. For example, we are instrumenting GMS for SOA environments and other. Whatever protocol is being instrumented can participate in this transaction. The data that is being sent, it's actually JSON-based typically. And we support the standard Zipkin standard, so you can use many different tracers to send the data. And it includes, in addition to the keys, the trace ID and the span ID, a lot of information that you want to know about this, whatever components send the data. For example, it will have the host name that it was running on, the app server name, the port ID that is reported here. And the user can add as much data as they want. If you use out-of-the-box tracer and agent, like the one we are providing, we will collect about 30 different attributes out of built in, and more can be added. Important things will be what, if you're running on Kubernetes, the node name that it's running on, the version of the application that it is actually executing right now. All this data is available and kept with a span, so later on it can be searched on. I'll move on to explain now. If I go back to this for a second, we have here the tracer and the agent, and I want to explain what is tracer and what is agent. From OpenTelemetry's and Opentracing perspective, we talk about the tracer. The tracer is something that implements the OpenTelemetry API, which means you can call it in your application and say, send start a trace, add the dimension to the trace, and attribute to the trace, finish trace dot finish, right? Finish the span, and that works great if you are using some JavaScript. That is very easy to use. But and if you're using new applications that are new microservices technologies, if you're using Helidon, Drop Wizard, Spring Boot, and so on, many times you can use libraries when you develop the application to include a tracer in the application, and you configure the tracer to send the data to our collector. But you may be using older application. Let's say you're using a SOA-based application or WebLogic-based that was built 5 years ago, or maybe 20 years ago. Instead of, so the tracer still exists and we still want the tracer, but we want to, well, there's nothing to call the tracer in the application. The application was written before the tracer was invented. So using bytecode instrumentation, we insert, these are our probes that looks at the code, at classes being loaded, and upload the data and create the code that will call the tracer. In OpenTelemetry, the new terminology, this is pretty new, it's called auto-instrumentation. This is actually our agent. This is a Java agent using bytecode instrumentation and that insert the spans that they call the tracer. So in these 3 boxes, we are looking at using an agent here. This is using a Java Tracer. Example is Helidon. if you want to use it, and I'll show exactly how to do this later on today, change some configuration file and Helidon sends the data out. You don't need to add any code. You don't need to make any changes to the application. That works. If you're using any third party, any other language, Golang, Ruby on Rails, Node.js, Tracer, Jaeger, and Zipkin tracers are available. We support the Zipkin format. This is how the format is being sent, the data is sent out to the server. And this is kind of the standard. Jaeger can be configured to send the format to use the Zipkin format too. And by that, we actually support everything that Opentracing and Open-Telemetry supports. Additional component here is the aggregator. So if you are deploying, this is optional. You can have each one of these tracer makes an HTTP call and send a span directly to our collector. But in some configuration, let's say you're running Kubernetes on OKE or elsewhere, and you have many server running on the same host, you may want to, configuration-wise, it may be easier to have only one component that actually goes out. So you can install an aggregator, which is actually a portion of this agent/tracer that runs as a daemon, and you can run it as a sidecar in your Kubernetes and configure all your other tracers or agents, send the data to it, and only that will send the data directly to the APM collector. One more thing here, or actually, sorry, two more things here. One is the browser agent, which we provide, and it's JavaScript that sends the data directly to the collector from wherever the browser is running. And the other thing is, this is actually an open API. So if you need to send data to the collector and you don't have a tracer, you can still generate an HTTP a JSON file with the data that you want to send. It's a well-known format, and send it to the collector, and it will participate in the transaction. So what is it that we do with all this data once we collect it? So the first thing, of course, is the diagnostics use case. This is the most obvious case. We are saving all the instances of all transactions. So if someone made a call yesterday afternoon and had an error in it, we can identify this specific instance and see exactly how it ran, what happens there, where the component that transaction went through, which of this component was running slower, which of them was running, was it running on server 1 or server 2 on the load balance backend servers that I have, and so on. We are collecting, as I said earlier, all the traces, all the instances, and 100% of them. There might be some questions here, how to handle very high volumes. Most of the applications that people will use, unless you happen to be, I don't know, Twitter, the volume is manageable, meaning if you have hundreds of thousands, millions of transactions per hour, maybe 10 million transactions per hour, this is still doable. If you have a billion transactions per hour, that may be, we'll be happy to take it, but that may be expensive. Still, there's a way to go about this. You, rather than sending all the transactions, you send only some of them. So customer can choose to enable sampling, and there's a sampling support in the both in the tracers and in the agent to allow you to manage a very high volume. I don't expect most people to run into a problem. The value of collecting all the data is much, cover the cost very nicely, and exactly that comes on the analysis side. So when we are, if you're reading a little bit about APM, Gartner or other vendors, they're talking about the unknown unknowns. You have your application right now, you're trying to solve a problem, and you wish you know what was going on. I had an example talking with someone on the database side. They're running this, the application have this sequels that happens, and some of them running very slow because the customer is generating query that is very complex. And the question was, well, how we will know how many of these, do we need to change something in our data to solve this, because there's a cost for it. And the developer said, no problem, I'll just add a recording here and I'll record how many transactions this type of SQL are running and how long they ran, and then we'll know in the end of the month. And then 2 minutes later, he said, well, I'll do that, but I wonder if this transaction, when they're running them, are they running it they're coming from the synchronize or called right from the browser, or from a report that runs slower. So we said, okay, so I'll add two different. I'll add this to the instrumentation and collect two different metrics for this. And then the question comes, well, on the synchronization wise, is this the one that the browser is still waiting for the response and it's asynchronized, or this is the one that they are expected to get an email later on? So when you're thinking about this, you don't know, when you have a problem, you don't know what is the questions that you would like to ask later on based on the data. If we are collecting all the data and we are saving all the data, at any point that you see a problem, you can go back 9 months, look at the data and see what happens there in the previous version, or what happens there over a period of 9 months. How many people actually asked for this transaction when they were running on Firefox from a mobile? There's no way that you know that you need to ask this data upfront, but you may need it later on. And if you're collecting all the instances, it's there, it's available for you for finding problems and doing trending. And actually, the data is very detailed enough to take it and utilize it with machine learning to identify trends that are not that obvious to see, and so on. I wanted to mention also the real user monitoring. Typically, people consider real user monitoring to be a separate portion of the APM, which is, of course, critical part of APM in general, but it also have a critical part in tracing, because the first step of your transaction many times starts at the end user. So we collect all the users using Opentracing type of technology. So the browser run on the agent runs on the browser and collects all data, and we can calculate updates. We can group by locations. We can group by type of browser and so on. But every step is also part of the transaction that you see on the backend. So when you are looking at some backend up, something that end up with a slow access to a log file, to some storage file on the backend, you can connect it to the specific activity that happened on the browser that injected it. So it's important to have on the browser side detailed enough information, support, for example, support for application in a page. So you know that this is a page update rather than a page load or partial page update, and so on. So I don't know if there are any questions that require answer at this point.
No, the questions that came in were answered already, Avi.
Okay, great. So I'll switch over to do a quick demo, and we'll see how that goes. So let me switch the sharing, and I'll stop share. All right, this is my application. Actually, before I'll go there, let me use the create a little bit of a track of action on the application time monitoring here. So I have a simple application here. It's Angular based. It uses Spring Boot at the backend. There's 3 services in this small microservices environment, and it uses autonomous ADW at the backend to get the data from. So I'll log in here as let's call it it is Benny. The password. Now I'm buying some wine in this case, and I'll buy a few wines. I can look at the details. I'm just generating a little bit of traffic here so we can see what it looks like at the back end. I'll buy some more, and I'm intentionally buying a lot here. I'm choosing the expensive wine. Let's put a couple of these. And I'm ready for shopping cart, and I see my list here, $1,300. It's my name, and I'm checking out. Taking a few seconds, confirm order, failed. I actually intentionally ran into a problem in the application. Let's see what this looks like on my application. Actually, I can do a couple more things here, and maybe work a little bit more with the application. That will not make a difference for our use case. So I'll just leave it out. So looking now at APM. This is our home page, the out-of-the-box dashboard. I'm looking at the monitor. This is synthetic monitoring data that I have. I have alerts here. The EUM data is here, and my list of server that I monitor are over here. And for each one of these, I can go and see the dashboard. But I actually want to concentrate on the trace side, on distributed tracing and what that will look like. So first, a quick look of this Trace Explorer data. This is where I see all my traces. So I have a simple query language here. Actually, it looks like this. This is almost all the instruction that you need to know in order to run the queries. It's some kind of SQL-like with some discount. So it's not as complex. It's a simplified version that works specifically for traces and spans. So I can select to see traces like I do here. I'm looking at traces and I see what fields I want to bring here. And you can see this is the list of traces, meaning list of transactions that the user executed here. And as I scroll by, I can see there are many of them, of course, and I can see the name of this is the name of the service, this is the name of the operation, and you can see all of these started with the browser. So the name of the service is I call it WS for Wine Store Angular. This is the browser data, and this was a full page update in this case, and that's also here, and the query that the user, the actual Ajax call ended up with was wine store / products. And it took 250 milliseconds to run. It ran through 17 spans, 17 steps in the application. And I can have a breakdown here. The Angular, 3 steps on the Angular, that will be probably one update and a couple of Ajax call. It went to the products web service, microservice, and through the storefront microservice. And actually, I can see the details of that. So if I'm looking at this like that, I see each one of the activities. Started again on this is every color here represent a new service, a new microservice, which the Angular is the first one. I mean, the browser, and then the storefront. The storefront was calling, this is a call to the product service, and then there was another Ajax call that happens at the same time, and its activity. This is, by the way, the end of it. This was a call to the database. On each one of these, I can see details. I'm looking at the top. I see details that I'm collecting. These are the default details that we are collecting per application. And you can see things like it was actually running from synthetic monitoring. So I have a vantage point here. This is the name of the user. Actually, I wanted to see the user, the actual transaction that I just executed. So let me go back and find it. It's actually easy to find. There's a couple of things that I can do in order to find it. There's some save searches here. For example, I can look at all the sessions, and by clicking on the button over here, I just brought something that we saved the search, but I can run it myself. And this is my user here. And I ran 35 traces, and within the last hour, and I see actually the error count, which suggests that to the error that I had earlier. We will get to that in a second. A different search is let me look by user, right? This is grouped by username. And all these requests is by username. I can let's do sort by ascending. I think Benny will be at the top. Yes. We'll calculate updex. We calculate page that the total response time here, and we can see what that means here on the request. But even if I know nothing, I can start with something as trivial as this, right? Right now I'm bringing the list of all the services, and I will say I want only where username. We can do like Benny, something like that. And these are all the traces for the last 60 minutes. And if I'll go a bit longer, I'll probably see a little, I'll see more transactions as I was running it earlier in the day, or maybe last night. So you see 91 of them came up here. So I'm looking for this is the activity that I did earlier. Actually, I want to see the username here so I can edit. We'll see, this is really Benny and not maybe someone else. Yeah, this is, oh, I had another Benny here too. Benny 2 as well, sometime earlier. So let's go for last 30 minutes. So I know this is just this one call. And I can, this is a sort of, let's do descent here. And this is probably the transaction that caused the problem. If I'm looking at that again, I see the errors here. So let's see again, this is the specific, if you remember, I clicked the confirm page and I got an error. And what was the error, right? So this tells me that there was an error somewhere underneath this span. So the page was updated and the Ajax call got an error. If I look at the details here, I'll see there was an HTTP status detail, bad request, 400. Yeah, the browser got the Ajax call returned with an error. Why did this agent return with an error? Because the servlet returned an error, right? This is the server call. And we can see it. This is running on Apache Tomcat. It's actually Spring Boot using our agent instrumentation. And that one returned an error and so on, and went through the multiple services. And eventually the errors actually started with the database here. And we can see that the database itself returned an error. There will be the SQL ID that was executed, the actual SQL that was running on. This is the actual database this is running on. You see it's running autonomous database. And I actually have a little bit more data here. I captured the real SQL exception that happened here. Value larger than specific precision allowed. Very detailed information captured through our agent in this case on the Java side. I may be interested to see if this happens a lot. Maybe I'll search for this operation, or even better, let's just take the exact database statement here and I'll search for it. So I can go back to the Trace Explorer, and then now rather than looking at the full traces, I'll look at specific spans. And I can do something like this, where a DB statement, maybe I don't remember what it's called like, so I'll search for it on the span. Yeah, DB statement equal this. And I'll get all the instances of it. Probably don't need this space here. And I see all the list, and I can sort it by duration. That way. Most of them are very quick. I probably want to bring the error here to see which one, how many of them were error in them. So I'm looking for a field that exists with the word error. I'll find the one that I care about, maybe the DB Oracle error code. So rather than doing something else, I'll just say group by the error code. Yeah, I can just do a group by Let me clean it up then. Show spans where insert the group by DB error. I'm not sure what exactly the error here is. Here you go. I can't order by field, specific field. I need to order by sum of error count rather by error count. So it will look like that. Order by sum of error count. That was the problem. So actually, if I last 30 minutes, I had only one error with this SQL. Let me look at this a little bit longer time. Only 5 times it was running with this error, and most of the time it's running without it. The problem was because of these are all the same error, right? So we already saw what the error code is. We can bring it up here. It's something wrong with the precision, which means the field was too big. I see I'm getting a bit late on the run, so I'll stop here. But the point is, I was able to find a specific transaction. For each one of these, I can see exactly, well, let's do something that was running maybe earlier in the week, and I can see the trace that this transaction participate. You see that all of them look the same. Find out which user execute this one specific transaction that had the same error earlier, and continue my investigation to find out what's going on. I wanted to cover several more things, so I'll stop the demo here and go back to the slide, because actually before that, the next step is what do you need to do in actually to start using it right now. And for this, I'll show you what you can do today to start working with this. The service available also as an always free version. So let me choose a different compartment. So if you have a tenant, an OCI tenant, and you can get one no cost for you, you can get a free tenant and select your compartment that you're running on. If you're admins of that tenant, you don't need to do any specific request, and create an APM domain. And I'm choosing to use the always free version. As you can see, it's limited to the number of spans per hour. So if you send more than 1,000 spans per hour, it will just throttle it. It will not accept more. And we save the data only for 31 days here. So when you're using it for development, 1,000 spans per hour. So if you have an application that clicks once a second, you're covered. If you have, once you go to test loading, load testing, and to production, of course, we would like you to switch to the paid version of it. All it takes is the create the data. That takes about a minute or two to complete. The only information that you need in order to use this is these 2 keys. Actually, 3 things. You will need the key that looks like that. I will delete it later on, so I'm not worried about the actual value here. And this is just a way to make sure that the data that we are receiving is from a known source. So you will use the key as part of the data that you send in. And the other part of the data is the endpoint that will show up here as soon as the creation, as the domain is being created within a couple of minutes. So that will be a URL. Once you have these 2 pieces of information, you can go back and monitor your application, and I'll show you how. So let me switch back to my deck here. That was the demo. We went through that step.
Avi, can I interject just a second? Because there was one question that came up, which I think is good to address. Should we worry about any security concerns or compliancy violations to like EU laws or HIPAA requirements? And I told them that the both the Java agent and the browser agent can be configured to omit things that you don't want to collect, and out of the box, the values that we're collecting or the metadata that we're collecting should not contain any secured or IP information. But I just wanted to check back with you whether you have any additional insights on that.
No, that's absolutely good. So the good thing is whatever is being collected or not is 100% in the control of the administrator of you, the person who implement the monitoring. And out of the box, we do not collect data that is not within the So for example, I show that we collect the username. It's actually something that you need to add. Actually, I'll show it right here. Out of the box, we don't do it. You as the administrator need to say, I want to add it because this is okay with my organization and with the rules that I'm following, and therefore it will work. This is how you would instrument the browser page, right? So this is the application that I showed earlier. It's a Angular-based application. So this is the index.html page. And the things in the red square is what I added here. They were not here as part of the when I generated the application from with the Google with the Angular command line. This is actually the data that we need, right? We download, add a script to download our agent. This is our agent, and this URL is the one URL that I didn't mention earlier on that we were waiting for to show up. Actually, it's this URL over here, and there is a static location to get the JavaScript, and this will also always be the current version of the JavaScript that we are delivering. I told you this is the data key. This is a fake number here, but this is where you'll put the data key, the public data key. By the way, there's a public data key and a private data key. The reason that we broke it to two is on the agent, you will use the private data key. Nobody will see it unless they have access to the host where it's running on. The browser, any user of the application can right click on the page and look, do inspect and find out this value. So we separate them. If someone decide to take it somehow instrument something that you don't want to be instrumented anymore, you can go to our administrator page, delete the public data key, and all the pages with this data key will be ignored going forward. And for your own, the pages that you do want to generate, you will replace it with the new private data key. I'm sorry, public data key. You can do the same with the public data key, of course, but with the private data key that is being used with the agent, it's just less likely that someone will somehow, it will get drifted to somewhere that you don't want it to be on. So back to the information that we do have here. I identified the service name. I always want the service name. If you want to provide it, it will come up as default, but that is important, as you saw it show up on all the pages. And I also want to identify it as a web application. This is already some attributes that I want to add to the application. I may choose to add more attributes here. For example, I want to put some version of the application that it's running on. I can choose to add a username. So I wrote a little JavaScript here that add the username, it will show a username. And I can choose to add anything else. So I can run a simple JavaScript here that capture, let's say, the amount of money in the shopping cart before I send it. And it can be done here or anywhere on the HTML where it's running, and add it to the APM RAM object. There's attributes 1 to 10 that are open, and it will later on, as soon as I'm edited here, it's available for me to summarize. So if it's a number, for example, it can go into the Trace Explorer, and the Trace Explorer, you can do sum on it, or searching for all the transaction that the money, the shopping cart value was over $100, for example. Can easily be done. If your application is not an Android, it's some other application, you still need to find a place where this to insert this page. So if you're running PeopleSoft, you go through PeopleSoft configuration and find, and there's actually we have instruction for that where you can put this code in. So that was the front end. The second end, the most common one will be, I'm assuming, using our agent, where you want to, let's say you're running, again, this is from the application that I showed the demo earlier, running, although it's microservices, I've still used our agent to do the instrumentation. And in our case, this was Spring Boot. And actually, this is the only thing that's required here, right? So first I'm provisioning the agent. This is one-time command that you download the agent from our website, the same place where I created the admin. You can find it over there. And it's actually in HTTP, so you can build it into your build process. And then provision it, that's actually put it on the disk, and that can be anywhere on your hard disk. It can be on a remote disk. It's not that important. What makes the application work, the instrumentation work, is adding the Java agent parameter here. So once I open this, will create the environment. I can create the parameter, and this is an optional parameter, the service name. I can override it for each one of the instances. So I can deploy this once and point many different instances. And actually, I can add many more parameters. Where do you want to send the log files, change some instrumentation configuration for specific server, and so on. Basically, the application is the instrumentation is adding this one line, the Java agent, adding our APM agent.jar to it. That will do the trick. This obviously requires restart of the application, because you need the Java to have the Java agent in it. The next item is how do we use things that are not Java, less common issues. In this case, Node.js. How would I go about to instrument a Node.js? And I'm using here a Zipkin tracer. So if you look up here, I require Zipkin, and actually Zipkin require a couple of other things. This is common knowledge, right? If you want to know how to instrument Node.js with Zipkin, look at search for it on Google. You'll find immediately. Actually, you'll find exactly that. This is the portion up here of adding the information of our agent, so of our service. So again, I'm using a data key, and I'm using our URL that we are sending the data to, and this is actually what the URL I'm creating the script here. That's the parameter here. It's this URL / this is the version of the API right now. Observation using the private span as opposed to public, right? Using public key. This is private key, so the word here is private. The data format is Zipkin, and the data key is whatever the data key is. The instrumentation of Zipkin itself. So let Zipkin know there's two parts of it. One is you use it. This is the case for Express, although there would be, if you look it up, you'll see solution for other type of packages that you use in Node.js. But you tell your application, your Express application, to use the Zipkin middleware. This portion is the configuration of the tracer to use this parameter. There's a two-part for it. As you remember, the application need to, this will handle the calls into the Node.js, right? The REST calls that comes in will be instrumented with this, but you also want to instrument the call out. So let's say that your Node.js is making a call to another Node.js, or maybe make a call to the Java application. So you want to instrument the backend. This is how you do it if you're using Axios. So rather than using Axios, using this Zipkin Axios that wraps Axios, and that will insert the trace ID and the span ID on the outbound call. So once you do these two options, these two things, your Node.js is instrumented. And I've tried it myself in several applications. It's very easy to do. It takes 10 minutes to get it to work. One more last instrumentation point, how to do this. Again, this is for Helidon. And actually, this is for how you would build an application, a tracer, if you're building something new, right? You're developing something new in Java using, and you want to use our tracer, or actually not a tracer. So if you're using our tracer, you want to add to your POM file. This is the location of our where to download the agent from. And once you add this first parameter over here, right, APM Java Agent Tracer, it will be there. Now, if you're using Helidon, you don't even need to add anything on your code, because Helidon has a built-in instrumentation for that. What you want to tell the Helidon to add this other entry class that will automatically load the Helidon, our agent there. This is equivalent. If you look at Helidon documentation, they currently have a way to do this with the Jaeger tracer. This is the difference. Does it say Jaeger here, or does it say APM here? and then you provide the URL, the data key, and the service name in your YAML file. So doing this to changing your POM and your YAML file for Helidon give you out of the box full instrumentation that Helidon support. If you are not using some other app server and you still want to use the tracer, you don't have the YAML option here and this portion, the auto instrumentation, but these two will generate, will get the tracer into the code. And in the code, you will write, you will add a command line, and it is documented. I don't have it on the slide, but it's in our documentation how to initiate the tracer. It's you just need to create a new instance of the tracer in the code, and then call it, wrap your REST calls with something that will call it the start and end span. See, I'm almost running out of time, so couple of this is actually as I said, this is a new service that we released about 2 weeks ago. We already customers used it ahead of time in the limited availability. We have ESG endorsement. This is a game changer. If you compare this to many of the non-APM vendors, many of the big vendors moving now to support Opentracing, which means they will say they are using the old style of APM where you have an agent that runs on the application, aggregate data on the agent, there's a lot of sophisticated stuff on the agent in order to send data up. And because Opentracing become popular, they add some kind of add-ons to support Opentracing. We are lucky. We started with Opentracing. We started later, so we were able to build our service built on Opentracing from the beginning. The agents are much lighter. There is easier coverage with less effort from our side to support, because we can say whatever support Opentracing, we support it. We don't need anything special here. Put a zip-key tracer on it and it works. So our advantage over the competition here is the simplicity, powerful, simple instrumentation, and powerful at the back end. Sorry. Last thing here about pricing. As I said, the always free version is available for you as the developer to start working it. This is not just a way to learn how to use the product. This is extremely powerful tools that you can get completely for free during your development time. Very easy to do, costs you nothing, and highly valuable. Hopefully you will like it enough, so your operation team, when you are moving to operations, you will start using it, and the pricing is based on actual usage. So the more you use, the more you pay. Of course, it participates also in this in the $300 free trial that you can use in Oracle Cloud in general. Lastly, for anything else on data and the latest videos and blogs that we started, there's a blog already there, and we will have more how to instrument, how to gain more value and instrument more type of applications. Go online to oracle.com. And I think this is about it. Any questions, guys, that we want to discuss? They have about 4 more minutes.
Right now, I don't see any open questions. Maybe I can just assume that there's questions on like where can we apply this to, right? And is it what Oracle services or Oracle applications do you think are a good fit, for instance?
So first, this is a product that, of course, we like to support Oracle, but we also support anything else. Microservices, whatever your latest, the latest that you are building is supported. Microservices, if you look at the architecture, everybody talks about Opentracing rather than configure it to use Jaeger that you put on on a Docker somewhere that goes away, run out of this space, need to maintenance and so on, you can take exactly the same thing, configure it to send the data instant from your Jaeger, send it to us. But we also support WebLogic. We support older application. If you're running on PeopleSoft, you can instrument your application. If you are an OCI user and you use VBCS, instrument the UI right now. Oracle Function is about to go live soon, and they will have built-in instrumentation. So if you write in your application, you have your microservices running on Kubernetes on OKE, making a call to function, coming back, going to then you call ADW and so on. You can get a trace that goes from starting in your VBCS, go through your microservices in the backend, your whatever code, your Helidon that you run on your Kubernetes. You can get a step directly from the function that you call, get the step back, get the call to the database, and so on. So the coverage is very wide, and even if you're running your application, the customer running from a mobile app, as long as our Java browser runs there, it's instrumented. If you're asking about what do I do if I have an actual app that does not support Java browser, right? Someone that built an app. If you look online, you'll see that there are some that's pretty immature at this point, but people already looking at embedding Opentracing for mobile apps. Once this is working, there's some example that works. You can send the data to us, and it also participate in the transaction, in the trace. I think we are exactly out of time. So if no more questions, I'll stop here. Anybody else want to add anything?
Thanks, Avi. This is a great presentation and demonstration. I hope everybody got a lot out of it. And if there's no other questions, I think we'll end for the day. Thank you so much for joining us today, and we hope you have a great day.
Thank you. Thank you, everybody.